Hello, everyone, and welcome. My name is David Talby, and my goal today is to introduce you to the Spark NLP open source library and help you in your next natural language processing project, so that you can get state-of-the-art results in really as quickly, as painlessly as possible. If you have any questions, please kind of ask them as we go. We're going to go through some slides, some notebooks. So just ask questions as you see them. After this tutorial, also I'll be available on Slack later during today, so you can ask longer questions there. So we're going to go through a quick introduction of what Spark NLP is, what is the library, what's kind of the what's the state of the library itself, who is using it and why. And then we're going to go through how just the basics of how you get things done, kind of the basic NLP tasks and how they are supported. And afterwards, we're going to go into more detail into some of the specific NLP annotators, which kind of specific analysis and pre-trained models that come with the library. So Spark NLP is an open source library whose goal is to provide the community with state-of-the-art NLP for Python, for Java, and for Scala. And with state-of-the-art, we're talking about really those three things: accuracy, scalability, and speed. So when the library started, just being based on Spark and being really the only library that's natively scalable in terms of an NLP library was a big draw for people who really needed kind of either the scalability or really the extreme speed, either on a single machine or on multiple machines. But the other big reason why Spark NLP has taken off is because of accuracy. And what happened is that deep learning happened to NLP about 3-4 years ago. And overnight, a lot of the libraries that we all know and love and use became quite outdated in terms of the achievable accuracy. And Spark NLP was the first to actually have kind of deep learning implementations of new models, new algorithms baked in right from the beginning. And really, the main thing we focus on when building this library is accuracy. And we'll see some examples later today. About a year ago, O'Reilly did kind of the annual big study on AI adoption in the enterprise, and that was, I think, the first major finding. There's been a couple of ones after that, after this one, but this was the major finding showing really Spark NLP is the most widely used NLP library in the enterprise. And really, if you look here at the list of all libraries, so it was TensorFlow, Scikit-learn, Keras, PyTorch, and then really the next one is Spark NLP. And other than kind of other, either cloud services or a bunch of tools together, the next one after it is, is it 8%? And that matches with what we have seen as well. Spark NLP is widely used in the industry for production systems, in finance, in healthcare, insurance, retail, life science, cyber, where people kind of really need to get work done in a production setting. And I would say the community has been growing very quickly in the past couple of years. These are some of the companies who have told us that they're using this in production. So you see some of the largest companies in the world, some of the largest kind of internet companies, finance companies, healthcare and life science companies, and academic institutions are using this. Of course, there are tens of thousands of companies who have kind of downloaded and are using this, and where we just don't know about it. If you are using the library or have case studies, please can reach out to us so that we can update and let people know. The big thing, the big draw for Spark NLP is usually is accuracy. And for this library, the one big promise to the community is that we will keep you the state of the art. One of the popular benchmarks is named entity recognition. When we say state of the art, really we mean it in the academic sense. Best of class academic peer-reviewed results. Okay, so what are actual metrics on public academic benchmarks that have been peer-reviewed and published, and we want to see if we actually get the best ones on those. The benchmark that you see is on the right is the EN Core Web LG dataset, which is one of the most popular datasets to measure named entity recognition accuracy on. And as you can see, kind of right now, really by far Spark NLP produces the best accuracy you can get. And it's significant. If you're looking at, if you make, half of the errors or a third of the errors that another library would make, then it's definitely something that you see when you build just normal applications. The reasons for accuracy is because it's a combination. It's a combination of just really having a team where all we do is we read the latest papers, we try to reproduce them. If things work, we deliver the production grade versions of that. It's part of it is the transformers and embeddings. So Spark NLP was the first to actually offer NER with BERT. That was just in production 5 months after the first BERT paper came out. And then later last year, there were additional types of embeddings. So now there's Elmo and others that are included. On the clinical side, initially it was BioBERT, but now there are kind of based clinical, basically different clinical embeddings that come with the library. And of course, the models are trainable so that you can very easily tune them to your own specific problems. In terms of scalability, so Spark NLP runs on any Spark cluster and scales on it. And I think just 2 weeks ago, there was an announcement of increased support for 6 more Databricks runtimes and additional EMR and SageMaker runtimes. But basically, the benchmark you can see was run on AWS EMR, I think about a year ago. Here really one advantage is that we rely on Apache Spark to deal with some of the hardest scaling issues. Like how do you do caching? How do you minimize shuffling across the nodes in the cluster? How you do execution planning, right? To really take advantage of caching and reducing network latency. And there's a whole, really this is the one thing that Spark does really well. And you kind of just get it out of the box. Of course, there are some caveats. Your actual speed up will heavily depend on what you're doing, right? So if you're building a CNN algorithm, which is by nature iterative, you're not going to get linear speed up. Okay. However, if you're doing inference, you probably will get linear or near linear speed up for a large number of nodes. So that's one thing to note. Another thing is that especially if you go to a larger number of nodes, then really how you configure Spark definitely matters. But there's a whole lot of documentation and community support on how to do that right. The other thing we really focus on is optimizing speed and making this kind of really the fastest library you can find, either on a single machine or on a cluster. To that extent, today, really the game has moved to taking advantage of modern hardware. And we work closely with Intel and with NVIDIA, both to really make the most of the new chips. This benchmark that you see on the right, it was on AWS, and it was to train a custom name entity organizer specifically in French. It's really to show how well training can work, which is something that's very easy to do in Spark NLP. And the goal was basically we wanted to compare runtime. So the goal was to get to the same level of accuracy, right? So the bars you see here, you can assume they're aiming for the same level of accuracy that you reach. And of course, you can tune that, if your needs are different. In this specific case, what we found is actually, and this is something that happens quite often with us, is that the latest Intel chips, the Cascade Lakes, was actually 19% faster and 46% cheaper than the NVIDIA and the Tesla P100, which was the latest one on AWS that was available at the time. And Intel definitely, they did a whole lot of work to make certain deep learning instructions heavily optimized. But I would say overall, yeah, we worked with both NVIDIA and Intel to make sure that really, whether you're training on CPUs or GPUs, you'll get the most out of the hardware that you have. Spark NLP is open source and it's Apache 2 open source. So no question asked. So compared to Stanford NLP, which is only free for academic projects, compared to Spacey, where the multilingual model have some problematic kind of share along attributes. Spark NLP and all its models are open source. It's production grade and heavily in use by multiple Fortune 500s, and there's a number of public case studies that are out there on really some of the largest companies in the world and tech-savvy companies in the world who use this and rely on this in production. It's very actively developed. So we had 26 new releases in 2018, 30 new releases in 2019. So we have a release at least every 2 weeks, and we're continuing the same rate in 2020. And this is really a combination of really just keeping up with the NLP space, which is really, we are in very exciting times now. And really state of the art keeps moving every few weeks. And there's a lot that, that we want to do and we want to achieve. And that's one thing. The other part of it is really just supporting the community. And one of the things that we saw happening as soon as we launched the library is there was an immediate need to support a whole set of environments from kind of, just Spark built from scratch to, Cloudera, Azure, AWS, Google, Databricks, other environments. And they really want to make sure it's easy to use the library in all of these configurations. And that also, there's a lot that goes into making that happen. There's also an active Slack community where really there are kind of daily discussions where people bring up kind of projects, issues, ideas, new papers, bugs that they find, and there's and you can get answers there. So that's another kind of really good resource if you're starting. So we say it's an NLP library. So next question, okay, is what does an NLP library actually do? And the goal with Spark NLP was basically to make sure that it's going to be the one NLP library that you can use. So that you do not need to use other libraries like NLTK or Spacey or GenSim or Core NLP. And this is really, first of all, just to simplify the API. It just, far fewer lines of code to write to get simple things done. It's one reason. The other thing, if you really want to do something that's scalable and distributed, then really your entire pipeline has to be scalable and distributed. Right? So it doesn't help if you're, if you can clean text and normalize text in distributed fashion, but then when you do training or you do NER or you do document classification, you have to go to a single machine. So in Spark NLP, you can do really everything: spell checking, sentiment analysis, train your own models, classify documents, all either on a single machine or multi-threaded or on a cluster. So that's all of that is there. There's a growing set of out-of-the-box pre-trained models and pre-trained pipelines. Last count was about a month ago, and I think there were more than 80 pre-trained pipelines and pre-trained models that come with the library. And as you'll see, once you have something pre-trained, it really is 4 or 5 lines of code, to do what you need. So in terms of really, if you're looking for really state-of-the-art, BERT-based entity recognition, sentiment analysis, sentence detection, spell checking, all kind of document classification, all kind of more complex models, really it's all there. So if before the strength of the library was that you can really very easily train and tune your own models, now that is still there. But really for most functionality, you will find things out of the box that are pre-trained and you can just start using. Here are the runtimes that we officially support and test on. So Java, Python, and Scala have kind of complete and consistent APIs. The Python one is by far the most widely used. And those are the examples we'll show today. We specifically target the NVIDIA and the Intel platforms in terms of hardware and make sure we take advantage of the most recent innovations there. And in terms of the clouds we support, so AWS, Azure, Cloudera, and Databricks are ones that we kind of regularly test on and make sure that the library works and scales on well. Of course, we also support Spark just in and kind of on-premise classic mode. So that's the introduction. That is a library. If there are any questions up to this point or anything you want to make sure that I cover, please write it down in the questions on GoToWebinar, and I'll address it as we go. Okay, moving forward, let's see how you actually do things within the library. This code, this example you can see here, shows you how you do sentiment analysis and shows you everything that's involved here. So you can see it's pretty simple. You import the library, import Spark NLP. This is in Python. You call Spark NLP.start to initialize it. And here what we're going to do, we're going to use a pre-trained pipeline for sentiment analysis. So a pipeline equals pre-trained pipeline and analyze sentiment ML in English. So analyze sentiment NL is the name of the pipeline we are loading. English is the language. And then once we have a pipeline, we just call pipeline.annotate. Harry Potter is a great movie. And we get a result object, which is a simple Python dictionary, right? And we can just look at the sentiment column of it and print positive. That really is all you need. And one really important thing that we've done a lot of work on is to make sure that if you want to use Spark NLP, really you don't need to know anything about Apache Spark or about Tensorflow or about transformers or embeddings, unless you really want to and you want to train your own and tune it. This is really all you need. So if you want to do, for example, sentiment analysis, 5 lines of code, and you have state-of-the-art accuracy. So that's one example. Here's another very common use case, which is named entity recognition. So the goal with named entity recognition in NLP is to recognize named entities within the text. So for example, if you have the sentence Chandler and Monica met in Central Park, you want to recognize that Chandler and Monica are people and Central Park is a location. What's important here is that you're expected to do much better than matching to a dictionary. Okay, so for example, Chandler, you should know it's a person and not the city of Chandler, Arizona. Central Park, you should know its location, even though it's a fictional location, right? So you're not going to find it by having a dictionary of cities or places. The reason you should know its location is because when you have two people and you grammatically say met in, then after met in, you can only have a time or a place in English, right? And this is not a time, so this needs to be a location. So really, you want your NER model to kind of understand those basic things about the grammar and where different entities appear. In order to do this in Spark NLP and and this is really using the state-of-the-art deep learning model that leverages BERT embeddings, then does CNN on tokens, bidirectional LSTM on CNN on characters, bidirectional LSTM on tokens, and then a CRF based on the BERT embeddings for this language. This is really all you need to do. You load the pre-trained pipeline, you annotate Harry Potter is a great movie, and it finds in this case that the first two tokens, Harry and Potter, are part of a person names, okay, which is obviously also a fictional character, but definitely a person name in this case. Here's another example, and this example is in Scala. Really just to show you that the syntax in Scala and the API in Scala is really exactly the same. Here what we're trying to do is spell checking and spell correction, which is another unique thing that Spark NLP provides. So we load a pre-trained pipeline. We say we want to do a spell check in English. And then we call pipeline.annotate Harry Potter is a great movie. And as you can see, the words great and movie are misspelled here. But if you look at the result, it gives you the tokens. And if you look at the spell column, which has the corrected words, you see that great and movie have been corrected. Okay, so this is just kind of a completely automated spell check. So obviously it works when, in this example, when in a sense it's fairly obvious what the correction needs to be, so that you can do an automated correction, right? If it's not obvious, it can give you recommendations, and then obviously you can decide if they're correct or not. So this is basically how you do this. I'm going to show just a few more examples in a notebook. Can you see the notebook on the screen right now? Is it possible to see them? Okay, I see. Okay, good. So let's continue with the notebooks. Thank you. Okay, so this shows using the entity recognizer. By the way, everything I'm showing you today are public notebooks. So if you go in general, so there was a hand raise. Okay, if there is a question here, you're welcome to either type it in GoToWebinar or even just unmute and speak. Everything I'm going to show you is on GitHub. So if you go to gitlab.johnsonlabs, so Spark NLP has the actual source code of the library. Spark NLP workshop has basically public examples. Okay, and in this case, we are under NLP workshop tutorials, verification training, and then we have both the open source version and then the closed source healthcare version. If you look at public, basically all the notebooks are here. Another nice thing is that all the notebooks here, you can open them, just click here to open them in Google Colab, so you can actually run them. right? So you don't need to install anything or download anything, right? And here, basically, we put in kind of whatever you need to set up in Google Colab so that it installs everything for you. But you just open in Colab, you click execute, and you can run this yourself. So you import Spark NLP, you start it, you can see the versions. And then in terms of using pre-trained pipelines, we're just going to show a couple of examples here, but here is one. We load the pre-trained pipeline for explain document, which is basically a pipeline that kind of explains what a document is. So it splits a document into sentences, does tokenization, stemming, lemmatization, part of speech, which we'll explain further on, and spell checking. So we load the pipeline. We just have a test doc which we just create here, and then we say, okay, pipeline.annotate the text doc, and we see what we get. Okay, so for example, a sentence gives us just the sentences. So here, as you see, the text was split into two separate sentences. French author will help pioneer the science fiction genre, and then the second sentence. Tokenization basically splits the text into tokens or words. So you can see the tokens. The other thing we can see here is parts of speech. Okay, so we can see that the author is a noun. We can see, for example, that where is a verb, right? Invented is also a verb. Okay, and we can see the other parts of speech. We'll go over lemmas and stems afterwards. Okay, but you can see, for example, that the word pioneer was spell corrected to pioneer with two e's. Okay, as one example here, see how all of that has happened. One other thing I want to show is being able to find, just scrolling down here, being able to find entities. So we'll show those. And here's another example where the sentence that we have is as follows: is Peter Parker is a nice guy and lives in New York. What we want to do here is find named entities. And what happens here is that two entities were found. So one is a person, so Peter Parker is a person. The other one is New York, which is a location. As you see, what you get is for each token, you can see O means that it's not part of any entity, per means it's part of a person, and then basically B means begin, and I means intermediate. Okay, so that if you have a chunk, basically you have an entity that's more than one token, that's how you know where it begins and where it continues. Okay, so if this was B pair, B instead of an I, you'd know that Parker is basically the second entity, right, and not the continuation of the previous one. Okay, so that's basically how you run it. It really is as simple as that. You call annotate, you look at the results, and you continue from there, and all the functionality is available to you that way. I just want to check if there are any questions. Okay, I see one, but I'll probably want to answer. Just a moment. Okay, so there's a question of whether Spark NLP can be trained to extract data fields from free unstructured text. Okay, for example, if you have a long text and you're trying to extract things like, for example, payment terms, people, companies, the answer is absolutely. Text extraction is actually one of the classic use cases of Spark NLP. And we're going to go through, there are different ways to do it. So one of them is, for example, here, name and entity recognition, when you want to extract people, places. But definitely you can extract dates, you can extract numbers, you can extract the currency, you can extract products, you can extract clinical information, right? So symptoms, drugs, diagnosis. And actually the next notebook we'll go over shows you how you can train your own model to do that. Okay, just to understand in a bit more details what happens under the hood when we run those few lines of code. So Spark NLP starts, actually will start an Apache Spark session if there isn't one. And if you really want to, it can also return that session for you, like if you need, for whatever reason, you need a Spark session variable. A pre-trained pipeline just loads the pipeline. It loads the pipeline into memory, the models themselves, and the embeddings. So basically all the resources needed to actually run this. Spark NLP actually includes an in-memory data store based on RocksDB. So that, for example, if we load embeddings, and BERT embeddings can be 2, 3, 4 gigabytes, we have done a lot of engineering work to make sure the different threads can actually share the same embeddings. We can distribute embeddings across a cluster if we need them. If we have multiple stages in the pipeline that need to reuse the same embedding, we only load them once. So basically, there's a lot of work happening here in terms of sharing, caching, kind of just the engineering work to make sure this works well. In order to run things, deep learning stages of the pipeline, like name native recognition, we start TensorFlow. We've done a lot of work to run it within the same JVM process that runs Spark, so there is no inter-process communication with Python, which is very significant in terms of just runtime overhead and memory overhead. The annotate call actually runs the pipeline, right? So actually runs the code that does, it calls the algorithms, right? So split into sentences, tokenize, get part of speech, and so on. For the deep learning stages, they run on TensorFlow, so we do use TensorFlow under the hood to do that, but as you saw, that is completely abstracted away. We use the embeddings as needed, right, to convert the tokens in the context of sentences usually into the embeddings, which is what is used. And then at the end, we convert it all to a simple result object. Okay, the main point is that for you as a user of the library, this is basically the list of things you do not have to deal with, right? Because all of that is done for you and managed for you under the hood. And this is really one of the big advantages of using Spark NLP if you're dealing with transformers or deep learning for text analytics. What I'd like to go over now is just go through some really kind of the key concepts in the library. So the first key concept that we already saw is a pipeline. A pipeline really is just a list of text processing steps. So we start with the basic text that we want to analyze, right? So it could be a long text. We create a document from it, and then we create, in this example, we create a document, then we create sentences from it. Then from each sentence, we create tokens, and then basic for example, from the either per token or per sentence, we can say, okay, calculate sentiment, for example, right? We can do it really per token, per sentence, per document, as we want it. So the way this works is basically we have a data frame, right? And each of those transitions creates another column in the data frame, right? So we have the document column, then we create the sentence column, which has sentences, then we create the token column, which adds tokens. The nice thing about this is that this makes it kind of trivially parallelizable, right? So if we have the entire data frame within one thread, we can just do it serially. But if you want to distribute it across machines, right, then each machine would have basically part of the data frame and would just add columns locally when it does the calculation on the documents that it's responsible for. The second key concept is an annotator. So basically each algorithm that takes in a pipeline that does a step, for example, like a sentence detector or a tokenizer, is called an annotator. And for example, here you can see, for example, the sentiment detector. So it's an annotator, right? We initialize it, initialize the algorithm, and basically tell it, okay, you start with this, you take the sentence column, that's your input, right? So basically you do a sentiment per sentence. The output is the sentiment score for that sentence, right? So basically we say create this output column within the data frame, and that's where you put your output. And then you can also do any other configuration, right? So in sentiment detector, in this example, we set the dictionary, but in other cases, you can set different hyperparameters of the algorithm, which embeddings you use, stopping criteria, and so on. So that's an annotator, and that's an annotator is one processing step. Another important concept is the concept of a resource. So resource is any external, basically data file that an annotator needs. So this means embeddings, dictionaries, rules, pre-trained models, pre-trained networks, right? So for example, if you're doing an NER, you need actual BERT embeddings, you need the actual TensorFlow graph, right? You may have other kind of pre-trained models or weights that you have used. So all of these are resources. And basically, resources are things that Spark NLP knows how to share, cache, distribute, or store locally. And that's done for you. The fourth concept that you need to know is a pre-trained pipeline. And a pre-trained pipeline is basically a combination of all the above. So it is a pipeline, okay, including all the annotators within it, okay, including all the resources. Okay, so basically, when we do something, like what we saw before, like we load the pre-trained pipeline, right? So we give the name of the pipeline in the language. It loads the pipeline itself. It loads any resources, so any other pre-trained models, annotators, embeddings, anything else that's needed. And that's it. It's going to be just good to go. A pre-trained pipeline has basically two important methods, which you can see here: the annotate and transform. Annotate takes one string and just processes that string. A transform takes a Spark data frame. Okay, so really the only difference between working on one string or working on a data frame that can be a petabyte big is really just calling a different method. And of course, if you are working locally and using pandas, then you can just do two pandas from pandas and use a transform method to process your data frame that way. Okay, here's an example of how all of these concepts work together, and this is to answer really to answer directly the question that was asked: how can you train your own model? Okay, and this is one of the things that really Spark NLP does really well compared to other libraries. And if you try to do this, even PyTorch, TensorFlow, Spacey, other libraries, you'd see that it's going to be a much longer thing to do. But here's what happens: you initialize the libraries, Spark equals sparknlp.start. You load the training data. So this for NER, so it's CoNLL formatted data. So you just treat the training data set. CoNLL basically has a line per token, and then for each token you tell it whether this is a person or this is a location or whether it's nothing. So that's it. You just show examples of entities that you in your training set. And then we build the pipeline here. The pipeline has two steps. One step is we come and say, okay, calculate BERT embeddings. So basically, when I give you text, calculate BERT embeddings. So we say we load pre-trained BERT embeddings, we load BERT weight case in English, and we say basically BERT embeddings are done in context. So what we tell it here is, look, you calculate embeddings for each token, but it's in the context of a sentence. So BERT embedding basically have these two input columns, right? The context and the actual token. And the output column, we call it BERT. So that's what the actual embeddings, the embeddings vector will be. And then we say, okay, the next thing you do is actually calculate named entities, right? So in the context of a sentence, you have the tokens and you have the embeddings per token. Those are the inputs. There's the label column, right? That's what you train it against, right? So that's basically when you train, that's what the label will be. And there's the output. Okay, and here we can set that max epoch, right? Which here we just do really as one. And then we define a pipeline. Okay, so if you do not use a pre-trained pipeline, then what you do, you can just build the pipeline yourself. So this is a pipeline with just two stages. We say, do to the BERT step, the BERT annotator, and to the NER tagger. And then to train, we just call pipeline.fit on the training data. That's it. Okay, and that runs the training. Okay, once you've done that, you have a model that you trained that's tuned. Okay, so you've done transfer language with BERT, you applied the deep learning model and on your training data. Okay, any questions on this? Okay, yeah, please write in the, if you want to answer now, please write them in the questions on GoToWebinar. If there's something longer or for answer later, just put it on Slack and I'll see it after the talk. Okay. So that's the example. There is also there is a public notebook that does exactly that, and you can see it running in Colab. So it's near BERT. If you're interested, just I can share the direct links to these notebooks. But actually, if you look within the presentation, the deck will be available. Then you have the link here. Right. So this is the link to the notebook, and also you have the hyperlink here. So you have that available to you. And what you can see here, this notebook actually is longer than what we'll go through now, because there's a number of different ways to train an NER model that are available here. But just basically, just as an example, I want to show you one of them. Let's do NER. Okay, I want to show. Just a moment. Okay, yeah, I want to show NER with Glove. Glove, it's basically different embeddings than the BERT embeddings. We also support Word2Vec and support Glove embeddings as well. So here's an example of how you would do that, just to make it slightly different. So we load Glove embeddings, so it's Word embeddings model dot pre-trained. So instead of BERT embeddings, we have Word embeddings. We load the pre-trained models. We opt them to be, in this case, not case sensitive. Then we initialize the NER stage. So similar, we give it the context. So in the context of a sentence, you find them that is on tokens, right? And use Glove embeddings. Here's the label, and here's where the output goes. We set epochs, we set a random seed, tell it, the validation split, and what kind of logging do we want? We also have an option to include a confidence score if that's what we want, and then we create the pipeline. Okay, so build embeddings, apply the NER, and then convert, which is basically converted to a more easily printable format. Okay, and then if you want to do the training, that's it. You call glove pipeline.fit on your training data. Okay, and that's all that happens here. As you see, one of the things, I'm not going to run it here, but training is actually very efficient on a single machine. Also, especially if I don't know if you've tried to use like Hugging Face or try to use Spacey, training will be usually an order of magnitude faster on Spark NLP. Or at least that's the feedback that's what we see, and that's the feedback we get from the community. Once you have a model, you can try to do inference. Okay, so the next thing you probably want to do. Here's an example. Right, so here we fit a model on prediction data, and we ask it to annotate this sentence. International Business Machine Corporation, IBM, is an American multinational, and so on. And you can see the result. Okay, so International Business Machine Corporation is an organization. American, in this case, it's a miscellaneous thing. And those are that's what the model has learned here. Okay, but to do it also, you just basically take the same pipeline. In this case, we wrap it in a light pipeline, which is something we'll talk about going forward. And then on the light pipeline, you call annotate. So once you have a pipeline, once you have fitted it, you have the option of basically wrapping it in a light pipeline. A light pipeline is also a pipeline, so you have the exact same methods. Light pipelines are basically faster if you have a small data set that you're working on. By small data set, we mean under 50,000 documents. And the reason it's faster is because it does not create a Spark task every time you call annotate. Okay, so our regular pipelines are Spark pipelines, Apache Spark pipelines, and the nice thing about them is that they scale really well. But if you're, for example, in this, you're working in a notebook and you're debugging, and you're really just trying one document, right? You're trying just a handful of documents. You don't want the overhead of creating a Spark task because that can be several milliseconds. So what you do is you can wrap your pipeline in a light pipeline, and then that just does not happen. And you're going to see, basically, you're going to see faster response times on smaller data sets. So light pipeline really are used in two primary cases. One of them is really just debugging, right? When you're working locally on a small data set. The other place where light pipelines are very, very useful is really if you're publishing your models as an API, right? And then basically the way I call your APIs, I call it with a single sentence, and then you return the results, right? And then you want to make sure that each single sentence works well. Okay, so check if there are any more questions at this point. So there is one. Okay, so there is a question about whether you can customize the underlying TensorFlow model. And yes, the answer is yes. You can create your own TensorFlow graphs in Python, save them, and then yes, you can use them within Spark NLP. Yeah, and then if you want to, so basically your options are either you can just use pre-trained models, that's one option. In other options, you can train on your own data, but use the TensorFlow graphs that we have already created. Or if you want to, yeah, you can actually create your own graphs. oops, sorry, went back to the beginning. We'll continue here. Okay. Okay, now let's talk about the actual features. So as you saw, where the magic happens in Spark LP is within the annotators, because each annotator is an implementation of an algorithm that you can customize, and if it's machine learning or deep learning based, trainable. So we're going to go through some of the things that come out of the box, starting from the simpler things and then going to the to the more complex ones. So the first thing that you usually need to do with text, especially long text, if you have multiple multiple pages, paragraphs, is split it into sentences. And the first question people usually ask is like, why splitting into sentences so hard? Can I just do a regex and look for period, exclamation mark, or question mark, and just go with that? And the answer is yes, sometimes if you have really a professionally written text, right, and professionally edited text. But it gets interesting if you're trying to look at social media posts or any messaging, okay, like SMS or or WhatsApp messages or speech to text when there's no punctuation. And then you really want an algorithm that is able to understand grammar, and for example can take the example here and split it into 3 sentences, okay, without any punctuation. So for that we have 2 sentence boundary detectors. There's one really simpler one that really is based on basically assumes punctuation, and there's also a deep learning based one which is trainable and helps greatly if you're dealing with things like medical records, transcribed text, transcribed legal text, and definitely speech, things that come through speech. The next annotator that you have is a tokenizer. And Tokenizer actually, there's much more complexity to it than you think, because there's a lot of kind of fine print on how do you want to tokenize. But basically, a tokenizer splits the words from a sentence that you give it. The next thing that you want to do is really do some basic cleaning, and for that you have the normalizer. The normalizer is able to remove or replace undesirable characters. Right, so this example really just cleans HTML, but sometimes you just want to clean a kind of weird or unusual characters, lowercase everything, right, or kind of make those kinds of simplifications of text. So it does that. Another nice thing that Spark really comes with is a slang normalizer. So if you're dealing with kind of social media or other text information that has a lot of slang, basically you can normalize that before you send it to further processing. So that your other pre-trained models really will do much better that way. So that's just the text processing step that's out of the box. The next thing that comes with the library is the ability to do stemming. So stemming is well, basically it's as it says, it finds the stem of each word, and the stem basically means the root of a word in a sense. And it basically means taking words and in a rule-based fashion, removing prefixes or suffixes. Okay, what it means, as you can see, is that, and obviously it's language dependent. What you can see is that a stem of word is not always a real word. So the stem of studies is study with an I. In contrast, there's also lemmatization, and that's also supported. The lemma of a word is always a real word, and the lemma of a word is basically it's how the word would appear in the dictionary. Okay, so for example, the lemmas of M, R, and is the word be. Okay, and that's something that stemmer will not be able to give you. A lemmatizer would also be able to tell you that the liver really is a liver, but lives should be lemmatized to live. So usually when you're performing document classification, topic modeling, you'd want to use either stemming or lemmatization, and which one really depends on the use case. So as I said, lemmatization always returns the real world. So if you want to show the lemmas to people, to end users, you usually want the lemma. Lemmatization misses some words. Okay, so for example, if you have a verb like Brexiting, which would probably not be a verb in your dictionary, lemmatization will just completely miss it, right? Because it's not going to be a dictionary lookup, while stemming would do it. So stemming works really well in those cases. And in general, lemmatization is faster, right? Because it just does a single lookup, while stemming can be fairly complex depending on how many rules and how many basically regex replace you need to run. It also depends on the language. Languages like English is actually reasonably easy. Languages like Turkish are really complex in terms of stemming and how they, and really it's the richness of how the language is able to build words. And lemmatization requires more memory because you actually have to hold the dictionary in memory. So those are usually kind of your trade-offs between them, and both are supported. After stemming lemmatization, the other nice grammatical feature is part of speech tagging. And within Spark NLP, this is a trainable model. Okay, and that's another important thing, because often we get asked, okay, kind of which languages you support, or what happens if I have my own domain-specific data, like healthcare or legal. So part of speech is a trainable model in Spark NLP. The sentence detector is a trainable model. Even kind of even tokenizer, stemmer, lemmatizer, of course, you can kind of configure and write your own. So part of speech tagger, as you think about, tells you basically what part each word plays. So it can tell you that she is a pronoun, right, and seashore is a noun, and the is a determinant. And this is mainly useful if you're doing name entity recognition. Okay, so if you're trying to recognize, for example, where something is, say, a person or a location, so just the fact that it is a noun and not a verb is a good hint, right? So you will not make the mistake of marking a verb as a person, right? Because it has the same name. So in general, part of speech tagging is used in those conditions. The next algorithm the library comes with is the ability to identify dependencies between different parts of speech. Okay, so in this case, the quick brown fox jumps over the lazy dog. So we can see that jumps depends on fox and jumps depends on dog, right? And you can see basically the grammatical tree of the sentence, of how the sentence is built. This is useful when you're building knowledge graphs. Okay, for example, let's say that you are analyzing financial documents and you're trying to automatically extract cases where company A acquired company B. Okay, so the first thing you want NER, because you want to recognize names of companies, right? And then you probably want to normalize the name of the companies, right? Which is another thing. So you want to know that IBM and International Business Machine and IBM Corp are the same thing. Okay, that's nice. But then the next thing and the reason you'll need dependency parser is because you don't just want two companies. You want to know who was the acquirer and who was being acquired. And for that, you really need the dependency tree to understand really just the grammar of the sentence, right, in a specific language. So if you're trying to build those trying to extract those kind of structured facts where there's kind of some directionality, right? So it's important who met who, where did people meet, when did they meet. Usually need to also look at the dependency graph. Okay, and that obviously requires understanding grammar specifically. And just a trivia question: this specific sentence, the quick brown fox jumps over the lazy dog. If anyone knows what's its significant in the English language, please type it in the question so I can see it. I can come back to it later. It's a pretty well-known sentence. Another set of things that the library supports out of the box is basically a set of ways to find things in text. So there's a text matcher, which really, it's really a kind of highly efficient algorithm to basically find text in text. So you can find things based on kind of token sentences or just look for text. There's a regex matcher to match based on regular expression, and there's a date matcher. So this date matcher finds dates, but dates do not have to be kind of specific. That's a trained model. So for example, I saw him yesterday and he told me that he will visit us next week. Okay, so in this case, a date matcher would find that yesterday and next week are dates. Okay, even though of course they're not formatted as such. And of course, I ran this a few days ago. When you run it, you will also actually know in this case that yesterday is basically the day before today, and next week is 7 days after today. Okay, which is really nice if you're doing anything from kind of if you're analyzing social data, if you're analyzing really any financial documents, any legal documents, product announcements, customer service calls, right? This kind of ability to really understand relative dates and convert them to structured data you can actually query on is often very useful. Another kind of weird type of search or the ability to extract data from text is a chunker. A chunker enables you to basically extract things based on parts of speech. So for example, if you look at this sentence, you don't want to see that tend to see is one verb, okay, even though it's 3 tokens. Okay, you want to see that that one dimension is really one noun. Okay, even though it's 3 separate tokens with their own separate parts of speech. So a chunker enables you to come and say, okay, here's what I'm looking for. I'm looking for verbs and parts of verbs that are combined, or I'm looking for a noun and all the adjectives before that noun together. Okay, and that's something that actually you need quite often when you're trying to extract. Really, it's called chunks of text that really mean together one concept or the same thing. So that's also there. Other than that, Spark NLP comes with 2 sentiment analysis models. One of them which is really rule-based, and the other one which is trained, which is machine learning-based. So if you have the training data, definitely use the machine learning one. If you do not have training data, you want to start with the rule-based one, right? Sometimes just enough. Sometimes use it as a as a bootstrap, especially if you're dealing with a new language or new type of text. And the sentiment analysis, as you expect, tells you whether the sentiment of text is positive or negative. The other thing, sentiment analyzer is trainable for, of course, it's trainable. And what it means really, it's trainable for different emotions, right? So if you're training a model and you're providing the label does not have to be positive or negative, right? Like this example, okay, brilliant effort guys versus worst customer care ever. People also do regularly train models for surprised or not surprised, afraid or not afraid, angry or not angry, offensive or not offensive, right? Using those really the same code and same algorithms. The other thing that is kind of a very popular text cleaning tool within Spark NLP is the spell checking and spell correction. And as you've seen this before, what we do is we take text and we automatically try to find cases where we think a word is misspelled, and then we propose the corrected word. There are 3 different algorithms to do this, and the reason you need 3 is because basically they provide different trade-offs of accuracy versus runtime versus memory. So a Norvig approach is it's a classic one. It works on a per token based, and you give it a dictionary. So basically, you give it a dictionary of the English language or the French language or the German language, and that's all it needs. Symmetry delete, what you do, basically you give it a large body of text in a language. So you can say, okay, here's all of Wikipedia in Italian. We think that's largely correct spelling. Learn from that. And then it learns from that, and it uses distance metrics to propose the closest word, right? If it thinks that a word is misspelled. The context aware, that's a really new model. We're just launching it. It's slower, but it has one ability that the previous 2 models do not have, which is to judge a word in context, and that's a deep learning based model. So here are some examples of context aware spell checking. So you can see, there are 2 sets of examples here. So in the first 3 lines, as you can see, we have basically the same misspelled word. It's the same token, really, right? So if your spell checker only looks at the token, it cannot possibly tell that these need to be corrected in 3 different ways. But the context-based spell checker, in this case, we say I will call my sister, which should be I will call my sister. Due to bad weather, we had to move to a different site, and we traveled to 3 different sites in the summer. Okay, so it will be able to give you the right correction based on the context of the sentence. And as you can see in the next 3 examples, also you have the exact same token, but you correct it in 3 different ways. And one nice thing, and that's kind of how it's working for us, with the PRIT model. We tested with this right now a couple of weeks ago. We have the last example. I introduce you to my sister. She's called Heather. And basically, it also learns people's names, right? Because basically, we just give it a large body of unsupervised text. So it does not have to be dictionary words, but if you have common names or locations, it will learn those as well. And all of the models in the spell checking area are unsupervised, right? Meaning basically the way the algorithm works is give me a large body of text that you think is spelled correctly, and that's fairly easy to find in every language. And then the model based trained on that, and you get the result. Of course, the caveat is, this works well when the misspelling is obvious. If the misspelling is not obvious, then like really every spell check you ever used, it will not always get it right. So there's there's a natural limit to what can be done automatically. Okay, before we go to using annotators, I would like to, are there any other questions that we should cover this time? If there are, please take the time to write them now. Okay, while that's coming, I'd like to walk through the next notebook, which shows the different annotators. And if you look at the workshop, so you go to Spark NLP workshop, you go tutorial, certification, public. There's a set of notebooks here, and we'll go over the first one. Spark NLP basics. I'm sure I think there was a hand raised here. Okay. And this is a Google Colab notebook. So if you click open in Colab, it will copy it to your own environment and you can run it yourself. And we've done all the setup here for you. Should be pretty easy, nothing to install, nothing to configure yourself. And let's look at some of the examples here. So I think, yeah, we spoke about Jules Verne already. So let's see, we tokenize. So we split two sentences, we tokenize. We look at parts of speech. So let's look at some. So here we do both lemmatization and stemming. So you can look at some of the differences. Okay, so for example, lemmatization, change science fiction, it basically remove the apostrophe. Stemming also remove the ION at the end of the word. Okay, so that's one thing that happened. Stemming is basically a bit more aggressive, so it changed Verne, the name, to Verne. It removed the E at the end, because that's the rule it applies by. Underwater, stemming will change to underwater. Okay, so that's another change that happens here. So basically, it really depends on what you're looking for in that sense. Right, so submarines, sometimes you want it submarine, which is the lemma. Sometimes you want submarine like this, which is the stem. And submarine is kind of the spelling. Here's another example. We have where submarines were invented. The lemma is B, okay, but the stem is the same, right? And the spelling is the same as well. Okay, and we also, I think we have one example here for misspelling, which is pioneer. But please, so not what happened. So spell correction corrected it, and then also both the lemma and the stem are actually correct here because they happen post spell check. Okay, one other thing to know is really, even though it's a Spark NLP library, really it interacts really nicely with pandas, or if you're using Dask, Array, or other tools, and that's probably a very common use case if you don't need if you don't need a cluster, right? You're just working locally. So you see, it's really kind of it's pretty easy. It just comes, okay, I just want to see it as a table, and people do this all the time. Yeah, I think we saw some of the examples here around basically adding name and entity recognition. So French is, in this case, this is a miscellaneous. Verne is a person, and I think these are the only contexts here. We have spell checking. There's ability to parse just really as an there's ability to parse a list of texts. So if you just give it a Python list and you send it to annotate, it will just annotate the list, and you can do this at once. Okay, and you just get it as basically as an array, and you get the entire result. Yeah, and I think we saw the Peter Parker example. I think it was one other notebook that I want to show. This is the basics one. Oh, I think it was this one. Name entity recognition at the beginning, and this is also from the same directory. Showing basically how to use a pre-existing pipeline and what are kind of the annotators that are there. So here the text is the Mona Lisa is a 16th century oil painting created by Leonardo. It's held at the Louvre in Paris. Okay, so we same thing. We load the Prepaid Pipeline. Just recognize entities. So it's the main entity recognizer. we annotate the text. So we call pipeline.annotate on the text. This pipeline includes the following columns, right? So we have the entities we recognized, we have the document itself, we have the sentences, we have the tokens, we have the embeddings, and we have the kind of the NER results. Here are the two sentences. Okay, that's the result of the sentence column. Here are the tokens. Okay, so we can see how this was tokenized. Here is the NER column. Okay, so we can see that Mona Lisa is a person, Leonardo is a person. This is a mistake. It says that it's an org. Then Louvre is a location and Paris is a location. Okay, entities is basically a nicer way to read the same thing. So Mona Lisa, Leonardo, we have it's here, we have Louvre, and we have Paris. Okay, now this is an example of really just a slightly bigger document. Okay, but really similar thing. You can identify, people, organizations, and that's done automatically. I can tell you in some, what I'd like to go through now is go through some of the case studies we have. Because there was a question here about basically how well this scales. So one nice thing about Spark NLP is that all of the case studies you see here are actually these are not marketing case studies. These are technical talks from Strata Data Conference, previous ODSC talks, O'Reilly AI, Spark Plus AI Summit, PW Healthcare, and kind of other large industry conferences where companies who use this came and presented really technical case studies. So if you follow these links and you look at the presentations, you'll see they show the actual pipeline they've used, really kind of what worked and what didn't in terms of deep learning, hyperparameter optimization, and also in some of them, like the Roche case study, and I think the Kaiser case study include accuracy metrics, right, for domain-specific case study. So you can see why they had to train their own models and what the results were there. So in terms of some of the examples, so the Roche example is around extracting knowledge from pathology reports and radiology reports. So this is obviously a healthcare-specific example to extract information about tumors in oncology. And there's a dual need to train custom models. First of all, because the grammar and the vocabulary of pathology and radiology reports is very, very different from standard English. So just off-the-shelf models just do not work at all. So really need to train your own. The other thing, in terms of information extraction, there was a need to extract very, very specialty-specific answers. Okay, so it's not about people and locations, right, or symptoms and drugs. It's about this tumor. What's the body part? What's the size of the tumor? What's the histology? What are the TNM values? Is it metastatic? Right, so basically oncology-specific questions. And this is very common in NLP in general, right? You come say, it's really nice you can get people and organizations location, but here what I really want to know, right, is some legal terms, some financial terms, some customer service kind of escalation questions, right, or specific clinical questions that you want to extract from the text. Another good example here is the select data case study. It's also in the medical domain around automated chart reviews. So the interesting thing there is just from a scale perspective. This is a pipeline that dealt with millions of documents, each one between 100 and 150 pages long, so long documents as well, which also meant that there was a lot of noise, a lot of duplication within the document, right? So unlike the kind of the demo examples I've shown you here, where there's one sentence or a few sentences, we're talking about really thousands of sentences, right? So you really need the model to understand where and why it's retrieving data from. And the other thing was the pipeline there it did OCR, then it did de-identification, and then it started basically its NLP pipeline, right, of splitting into documents, cleaning them, splitting into sentences, cleaning them, and then doing different types of information extraction. Other examples here, you can see both from the financial domain, right? So the work with UiPath was, and I think it was related to the previous question here, specifically working on long financial documents. And by long, we mean also like 200, 300, 400 pages. We were working there on documents that were basically annual disclosures by pension funds. And the goal was to extract, I think it was about 100 different fields or questions, and structured answers from the free text. So those, so the scaling issues in terms of length of the document, but also just the complexity of really finding kind of the the right dollar number from really thousands of dollar figures that were disclosed there within the many pages of the document. So it was an interesting challenge. So in general, if you're looking to learn more, the first thing I would start is really looking at those case studies. Other than that, there are other things that SparkLP has. Really? Sorry. So other than what we've gone through, everything we talked about today is available in the free open source package. Okay. Another thing that's also available free and open source are other language models. So currently the languages that are supported are Italian, German, French, and Spanish. Actually, that's not up to date. I think Russian models were released a couple of weeks ago. And right now what's under construction are Portuguese and Turkish models. And there's a lot of ongoing work to just expand languages. I would say that's another area where, if you're looking to contribute to the library, that's one area we're definitely looking for contributions with additional languages. It's fairly easy to do, as you saw, to train models, and like the library really is trainable. There's no kind of black magic that you need to know to train your own models or own language models. It's really more just getting the training data and running it. And we're definitely looking to support additional languages in the future. If there are specific languages that you need, please let us know. Other than that, there are commercial extensions to the library. So there are two of them. One of them is Spark NLP for healthcare. Where basically for that, there's a specific team that does the same thing that's done for general NLP for biomedical NLP, which is read the latest papers, look to see when people improve the state of the art or claim that they do. If they do, the goal is to try to reproduce it. And if it does reproduce and generalize, provide the production grade, trainable, scalable versions of that for clinical NLP. So that's one extension. The other one is Spark OCR, which enables you to do object character recognition at scale. So first of all, you can run it locally, you can run it on your own cluster at scale. But really, the big thing that it does nicely is accuracy, because it includes a bunch of automated image pre-processing steps that can deal with all kinds of noise, like denoising, automated skew detection, scaling within documents. But definitely, you should start, and most of the projects are done with the open source package. So one nice thing about Spark NLP is that you have quite a few public technical case studies of people who actually use the library. So you can see kind of best practices, tuning, scaling, right, and really kind of what you can realistically expect. Other than that, in terms of starting, and this is something I want to go through a bit. So the main homepage for the library is nlp.johnsonlabs.com. So if you go there, there's a getting started page. You can go obviously to GitHub, and there's the Slack community where you can go and ask questions. Definitely recommend joining the Slack community if you're starting to do any real work. And then, there's some examples here. Here's what comes out of the box, some benchmarks. But the main things you have here, you have the documentation. Okay, so if you want to know, for example, you want to know about the annotators that include in the open source package. So, here are all the annotator, and you come and say, okay, I want to understand the date matcher. You click the date matcher, and it comes and says, okay, here's what it does. Here are the kind of things it supports. Here's the function. Here's an example. You have Scala and you have Python examples for each one. It's pretty simple, and you can use it from there. So documentation is there. You have general concepts, pipelines, models. In terms of models, all the public pre-trained models are available here. And really, as you can see, there's a good body of pre-trained models that are available out of the box. Okay, and also you can see, yes, we have Russian, we have Spanish, Italian, German, French, and English on general ones. Yeah, there's also some of the licensed one are here, but sticking to that within English. Yeah, you can see. So there's a number of NER models, number of embeddings. There's universal sentence encoder, something that's unique to Spark NLP. then some sentiment models and spell checking models and dependency parser models. Okay, and really the important thing that's available to you, but also all of these are trainable, right? So even like dependency parser, spell checking, part of speech are trainable models that you can use. The other thing really to pay attention to is the Spark NLP workshop. So one thing that you have here is there's a Docker container that you can just, it's really easy. You do a Docker pull and Docker run. What's nice is that it comes with everything included, so you don't need to install, don't need to install Spark or install Python, install Jupyter. It comes with all of this. It comes with the library, and it comes with some sample data sets. So you can just pull the container, run the container, and that's it, and you have it running locally. However, the new things we've done, if you look under tutorials here, is that we have Collab, which really just enables you to run any of these notebooks just on Google Colab. Okay, which means that you don't have to install anything. Okay, what you do is you download this notebook, you load it on your own really Google Drive, and within Google Drive you just click and it runs. And Google provides you basically free CPU and memory to be able to do that, which is nice. Within each of these notebooks, basically we've put here, like here's everything that needs to be installed once. You just run this and Google Colab installs all the prerequisites for you. And then you have the code and you can see, basically you can see how this works. I think in this example, we train a POST tagger in French, right? So this is a prepare of learn notebook with people who basically are adding support for new languages to the library. Okay, so you can see here French tokenization. Here we are training with the Perceptron approach. We are training the part of speech tagger, right? And really it's the same thing. We just feed to training data and that's it. Okay, you can see here's data in French and you can basically see the results there. Okay, you can see the training run and then you can see the results. Okay, but that's definitely another online resource. So basically Spark and NLP workshop is one resource that you want to have. nlp.johnsonlabs.com is a resource you want to have. And the third one would really just be the Slack community. Other than that, if you have other questions, you always welcome to get in touch with Johnson Labs. So there's info at I'm David at. And if you have any questions about the library, here's my email, here's my Twitter, here's my LinkedIn. I'm always available for questions. Really, the goal of this project is really just to have to give it to the community, help as many data science projects, as many AI projects succeed as quickly as possible. Make sure that the amazing research that's done in the LSP space is available freely to as many people as possible. Which is why we keep improving accuracy, we keep adding languages, and of course just trying to make it easier to use every day. But really, we're always happy with the feedback. We're happy with any request that you have. Of course, we're happy if you'd like to contribute. And as you see, I mean, there's it's fairly easy to get on and start writing code and contributing. There's there's quite a few people who do that. But really, I wish you the best of luck and success in your project. And if there's anything I can do to help you, please reach out and I'll be happy to. So this is the presentation. At this point, I'll stop and I'll see if there are any additional questions. We can answer them now. If not, you're welcome to contact me later for questions or use the Slack channel, the ODSC Slack channel for questions later today.
Thank you, David. We'll be waiting for the questions. We have 15 more minutes.
Okay. Okay, so yep, I can see the question. There's a question of whether there is a Spark NLP version for Microsoft Windows. Is it .NET or binary executable without Python or Java? And is it free for commercial use? Okay, so I mean, people do use it on Windows, definitely. And I know this because we initially had bugs on this and we fixed them. So Spark NLP does run on Windows Server. That's one way to do it. The other way to do it is really just run it within a Docker container, right? And then you can do whatever you want in there, and it's just sort of pre-built containers that come with it. At that point, what it does though, what does happen though, you can definitely run it without Python. You can run it just with what you do need a JVM, because it needs Spark as a backend, and Spark runs on JVM, and you can just use a JVM process. So there's no C# API, but the APIs are Java, Scala, Python. But people definitely run it on Windows, and people use it on Windows. And we do work with quite a few people at Microsoft who use Spark NLP regularly. Yeah, I think the main thing is really you need to decide whether kind of which .NET language do you use to actually interact with it, right? Because you need to interact with the JVM process, or whether you just want to have it like basically be like a small either JVM or Python based API for a model you trained, and then just call the API to run models that way. But in any case, I mean, you can definitely do that from the open source version. Like I don't know of a commercial extension that would actually help you here. I don't think you need one. I would say in general, if the question is about does Spark NLP run on this environment, the answer is probably yes by now. Because honestly, I don't think the environment we haven't seen yet at this point. I mean, it runs on Hortonworks, it runs on Apache Spark built from source from the Apache code. It runs within Zeppelin, it runs within Jupyter, it runs on both Databricks environments. It runs on multiple versions of kind of the AWS and Azure and Google services. The other thing it runs, because it's really, this is not as a service thing, it runs as software. Most importantly, it runs really well in high compliance environments. So if you need to run it, for example, this happens a lot for healthcare, you need to run it basically on-premise within your firewall, disconnect from the internet. You can run it that way. So what you do is you install it, you download the models once locally, and then basically you just do not need an internet connection, and the software, other than obviously free and open, so like it does not call home, it does not send logs. And that's actually one of the reasons people prefer it sometimes over cloud services for things like OCR, entity recognition, just the fact that you can run it within your own environment completely. Okay, I think we can stop at this point. If there are any other questions today, really, I mean, you have my contact details here on the screen, and there's the ODSC Slack channel for this tutorial. So please reach out. I mean, I'll definitely check the Slack channel later today. And in any case, really, I hope this was helpful, and best of luck with your own projects.
Thank you, David.
Thank you.
Thank you.